Also what's called transverse hyperbolas, which is what we're going to do now, and that more better fits what we've been doing up to now. You're going to see why almost immediately, because the generalized formula for this looks something like x plus h squared over a squared minus y plus k squared over b squared equals 1. So first of all, why is this not something we've done before? They'll say. The minus. This is an ellipse, except there's a minus in the middle. When you have a minus, what happens is, instead of going in, they go out. Okay? Now, this gets a little tricky. When it's like this, it opens this way. And you might want to make a note of this somewhere. When it's like this, b squared minus x plus k, I messed that up, there should be k, that should be h, my bad, squared over a squared, which equals 1. Which way is that going to open? Oh, right now I should have, yes, it's going to open like this and this, okay? So if y minus x opens up and down, x minus y, side to side. That's something you just kind of have to know. That's not something that's going to be inherently obvious in what you're doing. Now I'm going to really quickly run through like an example problem. So I'm going to pick the points x plus 2 squared over 4 minus x plus, y plus 1 squared over 9 equals 1. Okay? How do I graph this? This is how we go about graphing these. We put my axis into play now. We go through the same process to find the center of my hyperbole. Hyperbola. Keegan, where's my center? I'm doing the example problem up here I just made up. So if you look at your paper, you're not going to find it.
Yeah, I can't see.
You can't see, so I'm writing on the board.
Is it 1 or something comma 1? I see that. Keegan something.
I can't read that either.
I see Keegan. Keegan something C something.
Okay, it's x plus 2 squared over 4 minus y plus 1 squared over 9 equals 1.
So -2
-2,
and -1.
-1. So I'm going to walk over here 2. I'm going to walk over here down 1. This is my center. Now, the center is a weird phrase because this is a hyperbola. The center is the center of the shape, but it's not the center of anything. It's not inside of anything. Right, it's not touching the line at all. So now I got to figure out what else I need to know. What? Right, this is kind of like an asymptote line. It won't cross this one at all. Okay? Now, next question you have to ask yourself is opening left to right or up or down? Keegan, which one is it opening? Left and right, because it's x squared minus y squared. It's left and right. Since it's left and right, what I'm going to do from here is I'm going to have to know how far from the center is my vertex. Okay? Now, the formula they have in there for you is your vertex is A away. So it's opening left and right. What's A? Well, 4 is A squared, just like before. So it's going to be 2 to the left and 2 to the right. So there's my vertex, and there's my other vertex. So far, so good? These can get messy. Okay.
Wait, how'd you
A,
get?
when it's opening left and right, we use the thing under the X to determine how far the vertex is from the center. It's like the ellipse, except instead of the ellipse being like this, it's like this. And so A normally defines where the edge of the ellipse is. Now it's going to define where the beginning of my hyperbola is.
So what does that 3 do?
3 does almost nothing, except I'll talk about it in just a second about the slope. But right now it does nothing for us. Okay? Next thing's foci. Foci is a little different too. Your foci is plain old Pythagoras. So it's going to be c squared equals a squared plus b squared. So that would be 4 plus 9 equals c squared. So my foci would be at square root of 13. Now, for this to be completely surrounding it, which way do I go? Do I go up or down? Or left or right, Keegan? If I go left or right, if I go up and down my foci, you said the curve's this way. Is it going around my foci? Remember, the foci by definition is what we're going around, right? And so it's going to be left and right. Does that make sense? So my foci would be root 13 this way. What would root 13 be? 3 and a little bit more. So right about here is my foci. And then 3 and a little bit more. Here's my foci. Okay? Okay, so far so good. Now, how do I draw hyperbole? This is how you do it. Your slope is always going to be your y value over your x. Why would it be y over x? Why would slope be y over x? Rather run, right? So what I would do is I'm coming from my center. I'm going to go up 3 over 2. Okay? I'm just starting. And I'm going to draw a dashed line that follows that. Up 3 over 2, up 3 over 2, up 3 over 2. I'm going to do it this way too. Not supposed to curve.
Really?
Shouldn't curve. So messed up. Now, whenever I draw this one, I'm going to draw the same thing going the other way with a minus sign in front. So it's going to be down 3 over 2. Down, so, and I keep going. So it's good? These are my asymptotes. So I'm going to draw my vertex. Starting here, I'm going to approach the line but never reach it. I'm going to approach this line but never reach it. I'm going to approach this line but never reach it. I'm going to approach this line but never reach it. And I'm done.
Wait, how do you find V again?
V is the vertex, so it's going to be, if I'm opening left, right, it's going to be the thing underneath the X, to the left, to the right. Right? Square root? This is a squared, right?
Supposed to be the bigger one.
That would normally be true, right? But in this case, it's not, because we're just talking, when you have X squared, it's going to open left, right. If you start with Y squared, it's going to open up, down. So the only thing that matters is, if it's opening left, right, it's this that determines where the vertices appear. If it was opening, if it was written the other way around, it would be the thing underneath the Y, which would determine up, down where my vertex is. Right? Because the general shape is going to be this. They're not going to touch in the middle. They're not going to touch in the middle. It's going to be how far from the middle it is.
And for the foci on this one, you add them instead of.
For the foci, it's a squared plus b squared, which is odd.
So.
But remember, the foci has to be now. The foci on the ellipse has to be inside. Foci in hyperbola have to be outside for it to curve around. And that's why it's got to be bigger.
So
A squared plus b squared.
Great.
Got it? Everybody try number 1. Try number 1.
Can you do that for us, Mr.
Try number 1.
Hey, it says 0, 0. Wait, what?
Here's the vertex. So far, so good? Now I'm going to go through drawing it, and then we'll worry about foci in a second, okay? So now, from the center, what's the slope of my asymptotes? It's going to be 4 over, that would be 2, wouldn't it? 4 over 2? Well, no, square roots. A is 2, B is 4. It's B over A. So it's 4 over 2, which by the way is 2, right? So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Keeping my line. I'm going to go whoop. Now do the negative slope. Negative 2 would be down 2 over 1, down 2 over 1, down 2 over 1. So my graph's going to look like this. Now, last but not least, what's my foci? They want to know the points for my foci. So 2 squared, which is 4, plus 4 squared, which is 16, square root, which gives me a square root of 20. Sit down! Which is 2 root 5. Agreed? So my foci, which have got to be in this direction too, are going to be 2 root 5, comma, 0. Where's my other foci? Negative 2 root 5, comma, 0. Well done. For homework, do the front. The front.